Now is the time to study about dihybrid cross. That means where we study of two traits together. Okay, two traits. We are going to first in the monohybrid cross, we just took one tall plant and one dwarf plant. So now we are going to study in such a way where we take in one plant, we will be studying about the tallness also of the plant, that is the height of the plant, and the suppose roundness of the seed. Okay, so in that matter, let's start with the P1 generation, parental generation. We have taken a plant which is tall and they have round seeds. Okay, so this is like, you can assume it to be the father, and we cross it with a plant which is dwarf in height and has wrinkled seeds. Can you see that we have taken two characteristics? One is the tallness, that is the height of the plant, and the other is the another characteristic traits that we have taken is the shape of the seed, round and wrinkled. All right, now from here we have to form the gametes. Very important step. What can be the gametes? We can take this one characteristics of tallness and this characteristic of roundness. Fine. And also another gamete will be one characteristic of tallness and one copy of roundness will be here. This is one gamete. Here one copy of dwarfness and one copy of wrinkleness will be here. Another one copy of dwarfness and another copy of wrinkleness will be here. Fine, we have formed the gametes. Now it's time to put in the Punnett square. Okay, so how shall we put it? This is the F1 generation, filial generation. So this is the Punnett square. Okay, on this side we put the male gametes and on this side we put the female gametes. Alright, so male gametes will be this side TR and capital TR. Female gametes will be small tr and the other is the small tr. Done? We have put it. Simple. Now just let's multiply. TTs are TT, capital R, small r, then this one and this one we will do capital T, small t, capital R, small r. Then here this one we take capital T, small t, capital R, small r, and again this one we take and this one capital T, small t, capital R, small r. Right, so we have found the children of this cross. Okay, and what do we find? That in this these children are all are in the F1 generation, all are tall and have round seeds. They are tall in height and have round seeds, but all of them are what? Heterozygous. Nothing like that of the parents who were homozygous in nature. All right, now it's the time to again take black. Now is the time to take, because again Mendel was wanted to see, okay, are they different from the parent one, how what percentage of difference can be there, and also like do any of the recessive characters gets expressed during this crossing. So he wanted to test all this, and so he goes for the second round of crossing, and in the second round of crossing he has now taken one progeny and the other progeny. Okay, so in the, shall I do it in next page? Okay, I shall do it in next page, we will have space then. So he has taken parental generation 2, he has taken capital T, small t, capital R, small r. Okay, this is one and has crossed with another 1. This is the fine. Now we have to find out the gametes. Now in the gametes video, let's do a rough work here. If you want to do a rough work, you can do. I told you the formula of 2 to the power n, where n is equal to number of heterozygotes, not homozygotes, number of heterozygotes. So what do we find here? How many heterozygotes are here? There are 1 and 2. It's not 3 and 4. No need to take this. Only one of the parent is going to do the work. Okay, so here what we find is that, so there are 2 to the power 2. There are 2 heterozygotes. That means 4 gametes will be formed. In what way 4 gametes will be formed? Now we have to find out. So in the gametes, always remember, we are going to take, let me rub all this, eraser. Fine. In the gametes, we have to take it in this way. That means the tallness and roundness, dwarfness and wrinkledness, and the 2 characteristics should be there. 1 copy of the characteristics should be there in the gametes. Okay, so what can be the gametes? Capital T and capital R. Tallness and roundness forms 1 gamete. Then what we can take is that 1 copy of tallness we take and 1 copy of wrinkledness. Fine. Then what can we do? 1 copy of dwarfness we take and 1 copy of round seeds. Then 1 copy of dwarfness we take and 1 copy of wrinkled seeds. Fine? Understood? You can write it in this way, or maybe you can make the gametes here in rough work. You can do and just write it in, rub it, write it in this way. Okay, you can do the rough work and then just write the gametes. Here also similarly, what can be the gametes here? The gametes will be capital T R, capital T small r, dwarfness and round seeds, and dwarfness and wrinkled seeds. Okay, by the way, one thing I would like to tell is that in some books you will find that this one, the dominant character is written first and the recessive character is written in the second part. Again, you will find in some books the recessive character is written first and the dominant character is written in the second. Now what I want to do is that purposefully I have written it in this way. Now what I want to, so that I can explain, what we can do is that we can rub it in this way and let's write the okay, sorry, just a second. Let's write the dominant character first and the recessive character later. Fine? Done? Okay. Now the thing is that we are going to write the Punnett square, the F2 generation, which is going to be a big one. I think you can erase this portion so that you get space to write. Then, okay. On this side are the male gametes and on this side are the female gametes. Okay. What are the male gametes? TR, TR, RT, or TR also you can write, and this is this TR. On this side, the female gametes TR, sorry, okay, just a second, this one will come from the first side. This one, we'll start with this. Capital TR, then this one, then we write RT, and then this one. Done? Now simple. Now just keep on doing. Let's do capital T, capital T, capital R, then this one, capital T, capital R, then this one, capital T, small small t, capital R, and then capital T, small t, capital R, small r. Again, now this one, capital T, capital R, small r, capital T, small r. Then comes your capital T, capital R. Sorry, not in this way. Capital T, then capital T, small t, capital R, small r. Again, capital T, small r, small r. You can keep on doing along with me also. Okay, then capital T, small t, capital R, capital T, small t, capital R, small r. Then comes your small t, capital R, then small t, capital R, small r. Then comes your capital T, small t, capital R, small r, capital T, small r, small r. Then comes your small t, capital R, small r, and small t, small r, small r. So one recessive character, complete recessive character has finally got expressed. Now what can we write? We can write it in this way. So this one will be tall and round seeds. Okay, this one will be again tall and round seeds. This one is also tall and round. This one is also tall and round seeds. Fine. Here what do we see? This is also tall and round seeds. This is tall and wrinkled seeds. One. Okay. Then this is again tall and round seeds. And this is again tall and wrinkled. Again tall and round, dwarf and round. I'm writing it in short, all right. Please don't write in short as I'm making this video, that's why. Then this one will be tall and round. This one will be tall and wrinkled, dwarf and round, and this one will be dwarf and wrinkle. See how easily we can find out the phenotype, that is how will the plant look, by just knowing the genetic code or genotypes. Okay, now till this much it's done. We have done the F2 generation and we have got this results. We have to now write the phenotypic ratio, that is what will be the phenotypic ratio. From here we have to, that is what are the physical features that we can see. Tall and round, how many tall and round can we get? I think now I need to change the ink. How many tall and round do we get? Tall and round 1, tall and round, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 tall and round, that is tall plant and round seeds, phenotypic ratio. Next we go to what shall we find out? Tall and wrinkled. how many tall plants with wrinkled seeds are there? Here let me change the color again. Here let me take it as purple. Okay, what are we going to find? Tall and wrinkled. Tall and wrinkled. 1, 2, 3, 3. There are 3. Tall and wrinkled. There are 3. Tall and wrinkled. Alright. Now next we have to find out how many dwarf and round are here. Dwarf and round seeds. That means dwarf in height and round in seeds are here. Let's change the color of the ink now. Yes, what are we going to find? Dwarf and round. 1, 2, 3. Last but not the least, we are going to find how many dwarf in height and wrinkled seeds are here. So what do we find here? Let's change the color of the ink now. Let's go with, no, not red. Let's go with this color, this body color. Only this one. 1. So the phenotypic ratio is 9:3:3:1. As per your syllabus, no need to study about the genotypic ratio, because then the genotypic ratio, if you want to know, let's go to the next slide. Genotypic ratio will be, genotypic ratio will be 1:2:2:1:4:2:1:2:1. Okay, so that one will be like how many pure dwarf are there, how many pure tall and round are there, how many pure dwarf and wrinkled are there. This is what is the genotypic ratio, which is not required for your syllabus. You have to just remember this one, phenotypic ratio, that is 9:3:3:1. I hope I have tried my best to make you all understand this part of the monohybrid and dihybrid cross. Please rewatch this video again and again. And yes, needless to say, I will be there in the live classes, online classes, so we can discuss about this. But before you come to the class, please watch this video, because this has taken lots and lots of efforts from my side to make this video for all of you and to make each one of you understand. See, for me, like, it's not that I will only teach those who are really very good in studies. No, I really want each one of you to score really good marks in bio. And so if you are interested in bio, then take up bio in 11th and 12th. If not, then please leave this subject with utmost respect, okay, because bio is such a subject that you may hate the subject, you may love the subject, whatever it is, but you cannot ignore this biology, okay. It will always be there till the last breath of your life. So that is the thing. So yes, that was from my side up till now. So meet you all in the online classes. Thank you and happy learning. Bye. Take care.